EasyPower's easy-to-use yet powerful software enables you to create single-phase models quickly and easily, and to use its capacity for power system design and analysis to maximize productivity and improve system safety. The key steps include inserting single-phase equipment, making connections of various wire configurations, and setting the service type for single-phase equipment. After the one-line and equipment data are completed, you can perform analysis such as short circuit, arc flash, and coordination on single-phase equipment. To start, here we show a simple three-phase system consisting of a bus and utility at 480 volts. From the equipment palette, we change our view to enable the selection of single-phase equipment. Now, we drag a single-phase cable and attach it to the bus. The mouse pointer displays 1 pH to indicate that a single-phase item has been selected. After the cable is connected, we can select the phase connection for the branch. The possible single-phase line-to-line connections from a three-phase system are AB, BC, and CA. The possible single-phase line-to-neutral connections from a three-phase system are AN, BN, and CN. We will select AN. A phase connector symbol appears at the point of connection. This indicates that the phase or wire configuration is different from the upstream bus. You can hover over the phase connector symbol to display the connection information. Next, we'll insert a load to attach to the bottom of the cable. Upon connection, EasyPower inserts a bus between the cable and the new load. The new bus is automatically assigned the base kV of 0.277 kV to reflect the line-to-neutral connection tapped off of a three-phase 0.48 kV bus. At this point, if it were necessary, we could double-click the phase connector symbol to change the phase connection, and the change would propagate down the branch. We will leave this as AN for now. We will insert a low-voltage breaker and enter the data for the cable, load, and breaker. This single-phase branch is complete. Next, we'll add a single-phase transformer and panel. First, we'll drag a single-phase 2-winding transformer from the equipment palette and attach it to the three-phase bus. In the phase connection dialog box, we'll select BC. Note that the transformer automatically gets the voltage rating of 0.48 kV on the primary side, since this connection is line-to-line at the three-phase bus. As we enter the transformer information, we select the checkbox for Center Tap Connection. This specifies the transformer as having a neutral grounded center tap on the secondary winding, the 2 side, making the service type 1-phase 3-wire. The system voltage for this is referred to as 120/240V. Note that if you do not check this box, the transformer secondary is treated as a 1-phase 2-wire line-to-neutral service. After we enter the impedance data for the transformer, we are ready to insert a single-phase panel and connect it to the transformer. When we open the panel data to view the connection, we see that the base kV of 0.24 is inherited from the transformer. This is the line-to-line voltage. The line-to-neutral voltage is 0.12 kV. The service field shows 1-phase 3-wire. In the panel spreadsheet, we enter the load data. The first circuit is a 2-pole circuit, rows 1 and 3, for which the load voltage is 0.23 kV, and the load is 2000 VA. The VA load is split equally between the load VA columns VA-L1 and VA-L2. In row 5, we enter 0.12 kV, 1 pole, and 500 VA under column VA-L1. We will add a low voltage breaker on the primary side of the transformer and enter the data for the breaker. Next, we'll add a subpanel and motor to the panel. First, we drag a single-phase cable from the equipment palette and attach it to the bottom of the panel. The Select the Phase Connection dialog box is displayed. From a 1-phase 3-wire system, you can connect 1-phase 3-wire, also referred to as LLN equipment, 1-phase 2-wire line-to-line or LL connected equipment, or one-phase 2-wire line to neutral LN connected equipment, using L1 or L2 hot or line conductors and neutral. Now we'll insert a single-phase motor to connect at the bottom of the cable. This automatically inserts a bus with a base kV of 0.12. After filling out the data for the cable and the motor, we will open the data dialog for the panel to select the subline information and fill out the protective device data. Finally, we will add a 3-phase service entrance breaker below the utility and above the 3-phase bus. The creation of the one line is now complete, and we are ready to perform analysis. On the Home tab, we'll click Short Circuit, and then click Fault Buses to fault all the buses and display the short circuit current. For a one-phase 3-wire panel that is fed by a center-tapped single-phase transformer, you can get different results for line-to-ground or line-to-line fault. You can choose the single-phase fault type in the Control tab of the Short Circuit Options dialog box as shown. Line-to-ground fault current will be higher than the line-to-line fault current when the fault point is close to a transformer. Now we'll demonstrate coordination. We will open the coordination focus and select the service entrance breaker and all the items in the circuit supplying the 50 kVA load. Then we'll click Plot TCC to view the time current curves. Now, we'll close the TCC plot and open Short Circuit again to perform arc flash analysis. We click Arc Flash and click Fault Buses to display the arc flash results. We click Arrange for Arc Flash to display a report of the relevant arc flash information. This has been a brief demonstration of the single-phase modeling and analysis in EasyPower. For more information about the wide variety of EasyPower offerings, please contact sales@easypower.com. Thank you for your interest in EasyPower software.